Python tutorial, Paired Prices Returns Correlation. Pairs identification consists of searching for paired asset prices which move together based on fundamental or technical factors and initially tested through the returns correlation coefficient. This topic is part of pairs trading analysis with Python course. Feel free to take a look at course curriculum by clicking link at description box below. This tutorial has an educational and informational purpose and doesn't constitute any type of trading or investment advice. Please read full tutorial disclaimer at the end of the video. Correlation coefficient consists of measuring the degree to which paired asset prices returns move together taking into consideration their standard deviation. It is used for evaluating short-term relationships. As a formula, correlation coefficient between asset Y and asset X returns is equal to, and then within the numerator we have the sum from the first to the last of the difference between asset Y returns minus their arithmetic mean multiplied by asset X returns minus their arithmetic mean. This is then divided by the square root of the sum from the first to the last of the difference between asset Y returns minus their arithmetic mean, that result to the power of 2, multiplied by the sum from the first to the last of the difference between asset X returns minus their arithmetic mean to the power of 2. Great. So let's go into Python PyCharm IDE so that we can study correlation coefficient with greater detail. Excellent. So here we are within Python PyCharm IDE. The first step within the tutorial is to do packages importing. So we're going to import numpy as MP, pandas as PD, and matplotlib.pyplot as PLT. The next step is to create the data object for the tutorial, which is going to be named data and it's equal to PD or pandas.read_CSV. Then we have the path to the data file, data directory, data file, paired prices returns correlation data as a plain text file with .csv or comma separated values. Index column as date, and we parse those dates as true. So going into the data file, as mentioned previously, this is a plain text file with .csv or comma separated values. We have three columns of data, dates, EWG adjusted, and EWQ adjusted. EWG corresponds to the ETF investment vehicle, which intends to replicate the MSCI Germany index, while EWQ corresponds to the ETF investment vehicle, which intends to replicate the MSCI France index. Adjusted because this includes adjusted close prices, which were adjusted for dividends and splits. Notice that data has a daily frequency, and it's from the beginning of 2007 all the way to the end of 2016, therefore 10 years of data. So let's go back into the code file. After we read the data, we proceed to delimit training and testing ranges. Training range is commonly used for pairs identification and pairs spread co-integration evaluation, while testing range is commonly used for pairs trading strategy calculation and performance evaluation. Notice that this training and testing ranges delimiting is only included for educational purposes, therefore it can be modified according to your needs. So first we delimit the training range, which we're going to name T-data, and it's equal to data we select from the beginning of the time series all the way to the end of 2014, therefore the first 8 years of data. We rename that corresponding training range data frame columns with dot columns, and we rename them as T for training range GER for German prices and TFRA for training range French prices. And then we create the testing range, which is going to be named F-data, and in this case we're going to select from data from the beginning of 2015 all the way to the end of 2016, therefore the last 2 years of data. We also rename its columns, and here the difference is that it begins with an F so that we distinguish it as a testing range. Within this tutorial, we'll only be working within the training range. So once we've delimited those training and testing ranges, we're going to continue to do the calculation of pair prices returns. For that, first we create two time series with the corresponding prices, T for training range, GR for German, FRA for French, and from T-data we're going to select their corresponding time series. And with this we're going to calculate the returns. So notice we create two new variables with an R at the beginning, so we know those are the returns, also within the training range for German and French prices. And from the previously created prices variables, the ones we created above, we calculate those corresponding returns with .pct underscore change one position. So this is going to calculate their arithmetic daily return. And then we do dot drop NA, so we remove any rows with non-availables within them. So the next step is we're going to visualize first the pair prices chart. For this we create a figure 1, AX or axis 1, which is equal to plt.subplots. And here within that first axis or AX1, we plot those German prices within the training range with their legend located at the lower left. Something very important about this chart. We're going to create a chart which has two vertical axes, and they are going to share the horizontal axis. That's why we create this second axis, or AX2, which is equal to AX1.twinx. So, as mentioned, two vertical axes which share the horizontal axis. Within this second axis, we're going to plot those French prices within the training range, colored in orange, so that we distinguish them from the German ones, with the legend located at the lower right. The superior title of the chart, pair prices chart, and we show the chart. And last, we do the calculation of those pair prices returns correlation. We print a blank space, then the title, pair prices returns correlation, and we do the calculation together with its printing with NumPy rounded for 4 decimal places, and we do the calculation of the correlation coefficient with pd or pandas.dataframe. And first, we include the German returns within the training range, and we join the French returns within the training range, and we calculate their correlation with .corr. Excellent. So let's go ahead and run this code file. Its name's already stored here, so we just go ahead and click run. Perfect. So that opens the running console. We'll briefly visualize those pair prices chart. There we are. So we have the pair prices chart. We have two vertical axes. The one to the left, that's related to the first time series that we added into the chart, which were those German prices within the training range. And then we have the second vertical axis, the one to the right, which is related to the second time series we added to this chart, which were those French prices within the training range. We can distinguish the time series with their corresponding legend. Colored in blue, we can see those German prices. Colored in orange, we can see the French ones. Notice that both of these share the horizontal axis with dates from the beginning of 2007 all the way to the end of 2014, therefore the first 8 years of data or the training range. Excellent. So let's go ahead and close this chart. And we see here within the console the printing of pair prices returns correlation. Notice that it's being printed as a correlation matrix. Therefore, first of all, we have a principal diagonal in which we have the correlation coefficients for German and German returns, also French and French returns, and we will be concerned about the correlation coefficient between German and French returns right here, or between French and German returns right here, both of these correlation coefficients which are equivalent. Excellent. So now that we finished studying pair prices returns correlation, let's go back into the slides. And as mentioned previously, this tutorial has an educational and informational purpose and doesn't constitute any type of trading or investment advice. Please, pause the video now so you can read the full tutorial disclaimer. Okay, so with this, we finish this tutorial. Thank you for watching.